so this is the first of what I'm probably going to make into 3 lesson videos for section 8.2, mainly because 8.2 can be a little overwhelming. It's Lewis dot structure, so I'm super excited. And so we're going to kind of break it up into where we just introduce it and do single bonds, then we'll go into multiple bonds in the second video, and the third video we'll throw in polyatomic ions. And so hopefully that'll be a little less overwhelming than if I put it all in one video. So anyway, let's just go ahead and dive in. So one thing that you'll definitely want for these 3 videos is a periodic table with the valence electrons labeled across the top. So you may already have one with the charges. So I'm just going to draw kind of a makeshift periodic table up here. And so remember, group 1 has 1 valence electron, group 2 has 2. We skip transition metals. And then it's 3, 4, 5, 6, 7, and 8, except for, of course, helium only has 2. However, since we're bonding, we shouldn't be using helium because it's already full and stable and inert. All right, so in ionic bonding, atoms transfer electrons to achieve noble gas configuration. So somebody loses, somebody gains, they have opposite charges, and they're held together. In covalent bonding, atoms share electrons to achieve noble gas configuration. So both atoms need more electrons, so they share so that they can both be fulfilled. So most atoms share electrons until they have a total of 8 valence electrons. That's referred to as the octet rule. However, hydrogen only needs 2 electrons to be stable because it's in the first group. The first energy level only holds 2 electrons. All right, so for our purposes right now, I'm going to make a very generalized statement that's not completely true all the time. But for our purposes right now of just learning, we're going to assume hydrogen needs 2 electrons total to be stable. Everybody else needs 8. Now there are many exceptions to that rule, okay, but we're just trying to get through the basics right now, okay? So we're going to assume hydrogen needs 2 to be stable. Everybody else needs 8 to be stable. All right, so a single covalent bond is created when 2 atoms share 1 pair of electrons. So how many is a pair of socks? 2. So how many is a pair of electrons? 2. So the atoms share 2 electrons to make 1 bond. A dash represents a bond which is made of 2 electrons. An unshared pair of electrons, or lone pair, is represented as dots. Okay, so here is a bond. Each dash, or bond, is 2 electrons. So here is 2 chlorine atoms bonded. Here's our bond. The bond represents 2 electrons that are being shared. And the single dots represent your lone pairs. Now, a lot of times, especially those of you who like to go on YouTube to look up the answers to the practice sheets, you'll see this as this, and they draw the 2 that they're sharing as dots also. Well, that implies that they're a lone pair. So if you see something like this on YouTube, which I understand, I see it on YouTube a lot too because I'm looking up pictures to put as my answers on my PowerPoints, I don't accept that as a correct answer. You have to have the shared electrons drawn as a dash. So just alter what you find online. Okay, I expect the shared ones to be drawn as a dash, as a bond. Anything that's not shared can be drawn as dots. Sorry, I get super picky sometimes. Alright, so these are our rules for writing Lewis dot structure. So what I'm going to do is I'm just going to kind of list an abbreviated version of this over here so that way I can just point to it instead of having to click back. So rule 1 is add up the total valence electrons. So I'm just going to put add VE negative. That's valence electrons. Number 2, bond the atoms with single bonds. Single atoms go in the middle. So I'm just going to put single bond. Well, here, let's just put bond atoms. Step 3, add electrons until each atom has a full octet or each hydrogen has a duet, which is 2 electrons. All right, so I'm just going to put octet / duet. And then step 4, add up total valence electrons in the Lewis dot structure and compare to the total for step 1. So I'm just going to put check the total. Now, in the beginning, this is going to be very confusing. It takes a while for you to fully understand this, so just bear with me on this. All right, so let me go through and kind of explain some of these before we do one. So out of total valence electrons, I'm going to give you the formula. So you just find the valence electrons on the periodic table and add them up. How many do we have to work with? Step 2, we're going to bond everybody with single bonds to begin with. And then single atoms go in the middle. That means like this formula would be CF4. Since C is the single atom, see how there's just one C? That's how I know it goes in the middle. Like H2O. O is the single atom, so I would put O in the middle and the H is bonded to it. All right, next one says add electrons until each atom has a full octet and each hydrogen has a duet. So we're going to make everybody stable. So I give enough electrons to everybody to satisfy either the octet rule or for hydrogen the duet rule. And then add up the total valence electrons. So I'm going to add up all my electrons that I drew in my Lewis-Dot structure and compare it to how many I'm allowed to have. Now, some of you may be watching this and your teacher, if you're not in my class, might have taught you a different way, where you give everybody the valence electrons that they start with and you kind of start matching them and sharing them until everybody's stable. The reason that I don't teach it that way is when you get to some of the really tricky ones, especially when it deals with coordinate covalent bonds where one atom's actually sharing more than one electron into the bond, and then it gets a little confusing. This way, it just works easily every single time. So if you know how to do it that way, that's fine. Just know that some of the more difficult ones are going to get a little tricky, especially when you get to exceptions to the octet rule, because then it's hard to figure out who's sharing what if there's 6 atoms bonded to one, because then how do you give this single one in the middle an octet? So that's why I choose to focus on this, because this just works for every single scenario. Because I teach AP Chem too, so I need them to know how to do those super tricky ones that they may need to do in AP Chem. And so I just teach everybody the same method. Alright, so it says write the Lewis-Dot structure for the following. So in the beginning for the easy ones, my method may seem a little more difficult than what you may have learned, but like I said, this works for literally all of them. Alright, so we have H2. So step 1 says add the valence electrons. So I find hydrogen on the periodic table. It has 1 valence electron. But how many hydrogens do I have? I have 2. So I say, okay, well hydrogen has 1, but I have 2 hydrogens, so 1 times 2 is 2 valence electrons. So that's how many electrons I'm allowed to have in my picture. Now once I add up the valence electrons, I'm not going to look at that number again until I get to step 4. Okay, because if you try to force it to work when you're on step 2 and 3, you may mess some of them up. Alright, so step 2 says bond the atoms. Well, I have 2 H's, so obviously the only option on how to bond them is this right here. Now remember, every time you draw a dash, that represents 2 valence electrons. Alright, so I bonded my atoms. Step 3 is make sure everybody has an octet or a duet. Well, hydrogen, here I'll put hydrogen next to it to remind you, hydrogen follows the duet rule, which means it needs 2 electrons. So remember, anything in the bond is shared. It belongs to both atoms. So that means there's 2 electrons that belong to this hydrogen, so it's stable, it has a duet. 2 electrons belong to this hydrogen, it's stable, it has a duet. So then step 4 is check your total. I'm allowed to have 2 valence electrons. I have 2 valence electrons. Now H2 is obviously the easiest possible one to do. So let's, step it up a little bit. Alright, so in this one, I promise y'all it takes a while for people to catch on. Like sometimes some people start getting it after this example, some people start getting it after this example, some people it's well into the next few examples that I show before they start catching on. Alright, so here we have Cl2. So I go to my periodic table. Chlorine is in group 17, so it has 7 valence electrons. And how many chlorines do I have? I have 2. So 7 times 2 is 14 valence electrons that I have to work with. Alright, so I added up my valence electrons. Step 2, I need to bond my atoms. So Cl2, obviously I only have one real way that those can be bonded, and that's like this. Alright, so step 3 says make everybody stable with an octet or a hydrogen with a duet. So they all want 8. So how many electrons are in this bond? Well, 2 valence electrons are in the bond. So right now, with the way I have my Lewis-Dot structure drawn, this chlorine has 2 electrons, this chlorine has 2 electrons, because of course they're sharing. So to be stable, they need 8. So if it has 2 right now, how many more does it need to get 8? It needs 6 more. So I say, okay, well here's 1, 2, 3, 4, 5, 6. So see now this chlorine has 2 from the bond, 4, 6, 8. So it's now stable. All right, this chlorine right now in my Lewis dot structure has 2 electrons from the bond. So it has 2, so how many more does it need to get 8? Well, if it has 2, it needs 6 more. So I said, okay, 1, 2, 3, 4, 5, 6. And so see, now this chlorine has 2, 4, 6, 8. So see, this chlorine has 2, 4, 6, 8. This chlorine has 2, 4, 6, 8. Because remember, the bond counts for both chlorines because they're sharing. Now, last step is check my total. So I'm allowed to have 14 valence electrons in my Lewis dot structure. So if you look, I have 2, 4, 6, 8, 10, 12, 14. So my totals match, and so that means I'm done. Now I know some of you are probably like, whoa, wait a minute. You said this one had 8 and this one had 8, so isn't that 16? Well, remember, when we're talking about how many each one has, we actually end up counting the bond twice. So see, when I look at this chlorine, I say 2, 4, 6, 8. When I look at this chlorine, notice I'm starting with the bond again. I say 2, 4, 6, 8. But when you're counting the total in the whole molecule, only count the bond once. Because I have students who will do that. They'll say, okay, well there's 2, 4, 6, 8, 10, 12, 14, 16. And they've counted the bond twice. You don't count the bond twice when you're counting your total. I just count. So 2, 4, 6, 8, 10, 12, 14, like that. All right, so let's look at water, because water, now we're moving away from just 2 atoms and we're mixing it up a little bit. All right, so first step is add our valence electrons. So hydrogen is in group 1, so it has 1 valence electron. But how many hydrogens do I have? I have 2 hydrogens, so I'm going to multiply it by 2. Now here's where it gets a little tricky for some of you. When you are using a subscript, you multiply. So hydrogen had 1, it had a subscript of 2, so I multiplied. Chlorine had 7, it had a subscript of 2, so I multiplied. Hydrogen has 1, it has a subscript of 2, so I multiplied. But once you're combining different atoms, you add those amounts. So then I'm going to say plus my oxygen, which oxygen's in group 16, so it has 6. Okay, so when you're using a subscript, you multiply. But when you're combining different atoms, you add. So 6 plus 2 is, of course, 8 valence electrons. So how do I know what goes in the middle? Well, remember, single atoms go in the middle. So H2O, O is the one that's by itself. So I'm going to put O in the middle and bond my hydrogens because, of course, step 2 is bond the atoms. Now, in reality, this is not the correct shape. We don't go into shapes in regular. If you want to know more about Vesper theory, I cover that in honors. All right, so we bonded our atoms. So step 3 is follow the octet and duet rule. So hydrogen follows the duet rule. So let's focus on hydrogen first. How many electrons are in the bond? 2. There's always 2 in the bond. So hydrogen has 2. So is it good to go? Yep, it's stable. This hydrogen has 2. So it's stable. So in other words, what I'm telling you is hydrogen is always stable with 1 bond. It shouldn't have more than 1 bond. It shouldn't have any extra dots around it. Like, see how chlorine has extra dots? It shouldn't have that because it's stable once it has 2, which it has 2 once it has a bond. All right, now, oxygen, on the other hand, follows the octet rule. It needs 8. So right now, it has 2 bonds. Remember, there's 2 electrons in each bond. So it has 2, 4 right now. So how many more does it need to get 8? It needs 4 more. So I said, okay, well, here's 1, 2, 3, 4. All right, so let's check everybody's octet and duet. So hydrogen wants a duet, 2 and 2. Oxygen wants an octet, 2, 4, 6, 8. So everybody's stable. So last step is we need to check our total. So I'm allowed to have 8 valence electrons. I have 2, 4, 6, 8, and so I'm done. All right. And so like I said, these just take some practice. Some of you, after water, you might have started kind of catching on. Some of you, you may still be like, what is going on? And that's okay, because we're going to do some more examples. All right, and these are just pictures that I pulled off the internet that have our examples. All right, so it says, write Lewis dot structure for the following. So maybe pause the video. I would definitely only try one at a time. Like pause it, check it, and then try the next one in case you make a mistake, because you don't want to make the same mistake 3 times. All right, so I'm going to assume you've tried VR2. So first step is add our valence electrons. So Vr is in group 17, so that means it has 7 valence electrons. But since there's 2 of them, I'm going to multiply that by 2. So that means there are 14 valence electrons to work with here. Step 2 is bond my atoms. So I'm going to say, okay, well, Vr bonded to Vr. Step 3 is octet and duet rule. Well, hydrogen follows the duet rule. For our purposes, everything else is going to follow the octet rule for right now. All right, so that means my bromines want 8 electrons. Well, right now, this bromine has 2 from the bond. 2 from the bond, so how many more does it need? It needs 6. Okay, so see, now this bromine has 2, 4, 6, 8. So it's stable and good to go. This bromine currently has 2 from the bond. So how many more does it need to get 8? It needs 6 more. So I say, okay, 1, 2, 3, 4, 5, 6. And see, now this bromine has 2, 4, 6, 8. So it is also stable. So step 4 is check my total. Because remember, the total isn't that important right now because we haven't gotten to multiple bonds. When we get to multiple bonds in the second lesson video, checking the total becomes super important. All right, so I'm allowed to have 14 valence electrons. So remember, don't accidentally count the bond twice. So I have 2, 4, 6, 8, 10, 12, 14. So I'm good. All right, so hopefully you got that one right. If not, just try HF real quick, okay? Pause it, try it, and now we'll look at it together. All right, so first step is add my valence electrons. H is in group 1, so it has 1 valence electron. A common mistake I also see my students make is that they will give H 2 electrons because they know it needs to. So when they add a valence, even though it's in group 1, they'll try to say it has 2. Remember, it starts with 1. It's trying to share to get 2. All right, so H just has 1 plus F. F is in group 17, so it has 7. So that gives me a total of 8. So see, if you messed up your total, go ahead and pause the video and try to fix it real quick. All right, so we have 8 valence electrons. So now we're going to bond our atoms. So we have H and F. So I'm going to bond them. And then step 3 is octet duet rule. Okay, another common mistake on this one is you try to make both of them have an octet. Hydrogen only wants a duet. Okay, the molecules do not have to have symmetry. A lot of you want them to. I like it when they have symmetry also, but they don't have to. All right, so hydrogen follows the duet rule. Well, how many electrons are in the bond? 2. How many does hydrogen need to be stable? 2. So hydrogen is stable and done. Remember, hydrogen should not have more than 1 bond. Hydrogen does not need any extra dots. Once it has a bond, it has 2 and it's stable. All right, so fluorine, on the other hand, follows the octet rule, so it needs 8. When in the bond, it has 2, so how many more does it need? It needs 6. So 1, 2, 3, 4, 5, 6. So now let's just check everybody. So hydrogen has 2, so it's stable. Fluorine has 2, 4, 6, 8. So it is also stable. Now, last step is I need to check my total. I'm allowed to have 8 valence electrons, 2, 4, 6, 8. And so I'm done. All right, so hopefully you got that one right. The last one's kind of tricky. Before you try it, remember the single atom goes in the middle. In this case, N is going to go in the middle, and your H's are going to bond to it. You can kind of set it up to look like a T or a Y. Those are the common setups that I'll see. All right, so try that one. I'll assume you've done that, and let's do it together. So N, our first step is, of course, add our valence. N is in group 15, so nitrogen has 5 valence electrons. Hydrogen is in group 1, so it has 1 valence electron, but since I have 3 of them, I'm going to multiply it by 3. Okay, so I have 5 for nitrogen, 1 for hydrogen times 3, so 5 plus 3 is 8 valence electrons. Step 2 says I'm going to bond my atoms, and I know the single atom goes in the middle. So nitrogen is the one that's by itself. So I'm going to kind of set mine up in a T formation. I'll see some of y'all sometimes kind of set it up like this, which is also fine. This is actually more realistic of what it actually looks like if you use the Vesper theory, which again, we're not going to do in here. I did that in honors and AP. All right, so we bonded everybody. everybody's bonded, so step 3 is octet duet rule. So let's go ahead and fix our hydrogens first because they don't need any fixing. Hydrogen follows duet rule. Well, how many is in the bond? 2. So this hydrogen has 2, this hydrogen has 2, this hydrogen has 2, so all my hydrogens are good and stable. All right, nitrogen on the other hand follows the octet rule. So right now it has 2, 4, 6. So how many more does it need to get 8? It needs 2 more. So I put 2 up here. And so now if you look at nitrogen, it has 2, 4, 6, 8. So everybody's stable. So last step is I need to check my total. So I'm allowed to have 8 valence electrons. I have 2, 4, 6, 8. And so I am done. All right, so hopefully you at least got one of these right. Now, before you move on to the next lesson video, where we're going to go over multiple bonds, you really need to be able to do these 6 examples that I showed you completely on your own. So you may want to retry them because until you get really good at following the 4 steps, if you move on to the next lesson video, it's going to get really, really confusing really fast. Because for a lot of people, the multiple bonds are the hardest ones to deal with. So real quick though, here are just my 3 examples that I pulled off the internet. And so like I said, just make sure you're really good at these before you try to tackle the next video.